Super. Perfect. So you see this is what we were talking about. Let me recap. We talked about processes and threads. So on your operating system, on your machine, so to say, you may have a number of programs running. Each one of those programs, it has its own process created in random access memory, and your operating system manages the execution of that program. Now each program, if it was just single threaded, then in that case you will have no choice but to complete one task and then start another and then start another and so on. That will bring not so good user experience, in fact very bad user experience. And hence all your modern operating systems, all your modern hardware operating systems and stuff all together, they provide you with a framework wherein you can have a program which is multi-threaded. I repeat, you can have a program which is multi-threaded. Multi-threaded program means while one thread is running, that means while one piece of code, one execution is happening in the same program, you can have another execution also running in parallel. So both will not block each other. They will both proceed further, giving better user experience. So I gave you an example of YouTube player wherein you can use multiple, they have written the entire program of the player in such a way that one thread downloads and the other thread starts playing, and one may not be really dependent on the other. So this is what we have already discussed. Now few important things here. So as far as our Java is concerned, that Java also is completely multi-threaded even before coming down to Java. So what happens here is that, see, I talked about this multiple threads. This is a process, this is a program. Now when see in this computer, this is your computer. This is what so let me copy this and let me once again bring this out here, and I will just simply drag it and leave it over here. So if this is the program that I was talking about, not the JVM, suppose this is the program if I am talking about. So this program is again where is this program? This program is there in the random access memory. So this program is over here. So whatever the program is, whether it's Java or anything else for that matter, whatever it is, it may not be the JVM, it may be something else like the player program here in this case. So if there are these many threads that are running, each one of these threads is scheduled to execute on one of the cores of the processor. Why is this scheduling important? Because we have understood the fact that it's not necessary that one single program may be running on your on your machine. There will be several such programs running. Each one of those programs will have its own threads, maybe one thread, maybe 100 threads, whatever the number of threads are. So in a program there are threads. Many programs are running on your machine, but the total number of cores on your machine, for example here in my case, is 4 cores. You remember I gave you an example that if I have one table and if I have 10 people to share that table, then in that case there must be some kind of scheduling mechanism. There must be some way, there must be some method to madness. Like, okay, if all of them want to come and work on this machine, then wait, first you come, you take 10 minutes, go back. Another person comes, take 10 minutes or 15 minutes, then you go back, and then the other person who had gone back again gets a turn back again. That person comes back and starts working. Similarly, each and every program, it has got many threads. Each thread needs the computing power of your machine, and it is the thread that executes on the core. The actual execution of the instructions happens in the core. It happens on the core. So one processor may have several cores, and if I say that each thread is executed on one core, note my words, one thread, if this is the thread that you have, if this is executing on one core, so till the time that thread is executing on that one core, if another thread also wants to execute, and that's the point. That's exactly what the point is. While one thread is executing, you must be able to execute another thread as well, and hence you will get better user experience. So if another thread also is supposed to run in parallel while one thread is already running, so my dear friends, don't you think your operating system will efficiently pick up that thread and execute on another core? Come on, tell me yes or no. So with this, you tell me how many threads can execute at one point of time on one core. Tell me how many threads can be executed at one point of time on one core. Tell me. Abhijit, you may want to put your video off. It will save some bandwidth for you. Thank you. Yeah, so correct. Very good, Manisha. Very nice. So when you say many, that's also not wrong, Devdeep. You are right. You're not wrong. But at same one single point in time, exactly at the same point in time, how many threads can execute on this machine, for example, which is 4-core machine? If it was a dual core machine, then how many threads do you think will execute at one point in time? Very good. If it's a dual thread machine, dual core machine, dual core, not dual thread, dual core machine, 2 threads at one point in time. And if it is 4-core machine, 4 threads at one point of time. If it is a 8-core machine, 8 threads will execute exactly at one point in time. 8 threads will execute. And if it is a 16-core machine, 16 threads will execute. Yes, there are machines with 16 cores, 32 cores on your machine on cloud in the data centers like Amazon, Azure, Oracle, Google. They have got data centers where they provide machines with 16 cores, 32 core machines. So at one point in time, 32 cores, 32 threads will execute. Now I have a question to you all. Come on, friends. So if you have, suppose on this machine, how many threads can execute at one point of time? 4 threads can execute. But we did talk about the fact that at any given point in time, there can be other programs also running. So I may have another program. Perhaps that program is a Java program. Perhaps, that is my Java program. Java, right? And then, Java program, and then perhaps I have another program running which is maybe MS Word, right, or Excel. Maybe Excel is running on my machine, and maybe some other programs as well. So this will also have its own threads, not one but several threads here. This will have its own threads, okay, and so on. This will have its own threads, and then you also will have threads in Excel, the threads of Excel, right? Excel is also a program. Internally, it may be creating threads in order to do things in parallel. So now tell me, all of these programs are running on my machine. I repeat, all of these programs are running on my machine. And each program has got its own threads. But the number of cores on my machine is 4. I repeat, the number of my cores on my machine is just 4. Okay, the number of cores in the processor on my machine is just 4. And there are hundreds of threads that are there across multiple processes that are running in random access memory. How do you think? What is the term that you would like to? I did use that term several times. Tell me, what is the term that is used? What do you think the operating system is supposed to do so that it can efficiently get hundreds of threads executed in the limited number of computing resources, that is just 4 cores? What do you think is the term used? Tell me. Yes, Udit. Very nice. See, Udit says scheduling. Very good, Pooja. Very correct. It is scheduling. So it is the responsibility of your operating system to schedule the threads to execute on the cores. I didn't say processor. If at all you end up saying processor, you will not be wrong. But even if you say processor, on in the articles that you read on the internet, the books that you may read, it may still use the term processor, but essentially what are they trying to say? That the thread executes on the core. So at any one given point in time, though I have one processor, but it's a multi-core processor, 4 cores, quad-core machine. See this here. See this here. How many? Okay, well, on my machine, I have 8 cores. This is the latest Mac. I have got 8-core machine. So I have 8 cores on this machine, and there are 8 threads that will be executed. In fact, not 8, even double the twice the time of the number of cores. It will execute 16 threads. We will come to that later, but as of now, physically there are 8 physical cores on the processor and 8 threads for sure. Actually, as I said, not 8, actually 16. We will come to that point later. Because hyper threading is enabled on this hardware, it is capable of executing 16 threads on 8 cores. It further divides the resources of each core in such a way that 2 threads can execute on the same core. Hence, I'm saying 8 cores, but 16 threads will execute. Well, don't worry about that, but at least definitely 8 threads will execute. Even if hyper-threading is not available, and if you have 8 cores, 8 threads will execute. So don't you think, my dear friends, now I want an answer from you all. Which machine, so to say, will work faster? The one that is a dual core machine, or the one that is a quad core machine? Which of the two machines will be faster? Why? Because you are right, exactly. Why? Because the computing, exactly. Very good, excellent, good answer. So you've got to keep on pepping me up by giving answers. Beautiful. So why would a quad core machine work faster? The reason is that, yes, more computing power. At one point of time, many threads can execute. So very few threads will be lined up. So more the computing resources. If you have, just imagine, I'm sure each one of y'all at your home, I'm sure without any doubt, I'm sure each one of y'all at your home, y'all have that burner gas on which you cook food. There are two burners at least, right? There are two burners at least. See this. Now you have 4 burners here. Don't you think this will be, don't you think here you will be able to cook rice, dal, sabzi, and maybe something else as well in parallel? Don't you think you will be able to finish your job faster here as compared to the one which is just 2 burners? Okay. I hope I get one. Okay, no products, I'm sorry, but anyway, I'm sure. See, this is 3, right? I've got 4 out here. This is again 3, and this is 1 2 3 4, again 4 here. You see this would definitely be faster, right? Isn't it, as compared to the one that is here, which is 3? And then you have 2 as well, two burners on that entire thing. I don't know what you call it actually. So whatever the case is, I hope you're getting the point. I'm able to convey the point across. It will be faster. So because you will be able to do loads of things in parallel. Maybe still, you do have, so again, it's in a restaurant. Let's take the same example of the burner itself. If you have a small restaurant, but if you've got one burner, one particular, that unit, but with 4 burners, and he can cook 4 things on top, on it, 4 things. But then if there are many things, there are 10 tables on which he has got customers sitting in his restaurant. And there are orders coming from all of those 10 customers. Of course, there are 10 dishes to cook, but he's got 4 burners. So 4 things will happen in parallel, but the rest of the things will have to be, one word answer, will have to be, come on, will have to be scheduled. Excellent, Ananya. Very good, Manisha. Will have to be scheduled. Exactly, will have to be scheduled. Perfect, will have to be scheduled. And that scheduling algorithm is the responsibility of your operating system. I repeat, the scheduling algorithm is the responsibility of your operating system. It is your operating system which is supposed to run all the processes. Your operating system rules. It is your operating system that runs the hardware. It is the operating system that provides the infrastructure for your hardware and also the entire, the set of programs that are running on your machine. It provides the infrastructure. So you see this is how it works. Multiple threads, each thread will have something or the other running in Java. Another thread will be doing something else, another thread will be doing something else, another thread will be doing something else. And your course, your operating system will schedule the threads in the scheduler, and it will pick up the threads from the scheduler and get it executed on the core based on the priority of the threads. Please repeat this point. Based on, so the OS scheduler will schedule the threads to execute on the core based on, I did mention one term, based on what? priority of the threads. There are some threads which are, priority. I want, the code that is written in this thread to be executed faster, or it must get the chance to execute faster as compared to the other threads. So there are some threads which are low priority threads. There are some threads which are high priority threads. There are some threads which are medium priority threads. They will compete with each other, and your operating system will pick up those threads one by one and get it executed in the core, and your execution happens. Right? That's how it is. That's exactly how it is. So based on the priority of the threads, and then what it does is that it also gives a time slice. It gives a time slice that, okay, this thread, it calculates the time slice dynamically, that, okay, maybe 10 microseconds will be given to the thread. It executes, it goes back to the run queue, it goes back to the queue in which it maintains the list of the threads that needs to be executed. Then it takes another thread, it executes, goes back to the run queue, comes back on the core, runs, it gets it executed, and when the thread is completed, it throws it away. The thread is done, it's done, no problem. It's quite possible. It is also possible that I have my Java program and only one thread is running. All the other threads have completed their job, and the only thread running is, some thread that is running. And when that thread also, when there are no threads running in a program, when there are no threads running in the program, that means the program is not running and the program will exit. I will repeat once more. When there are no threads running in the program, that means there is no job to be done by the program. Your program will exit. One more time. If there are zero threads running, if there are no threads running at all in your program, the entire program will exit because it has got no job to do. Do not forget the point I mentioned. I made that point I did emphasize on the point that the scheduling entity is not the process. It does not schedule the process to execute. Yes, there was a time when the processes were scheduled to execute. Those were the days when multitasking was not there. So the multitasking was there, but only in mainframes where you had multiple processors. Okay, I don't want to go into that route, and I don't want to take the discussion in that direction, but the point here is that those days are gone. Now you have processors, you have got multiple cores, and your threads are the scheduling entity. So the operating system will not schedule the process to get executed on the core. It will schedule a thread, and at any given point of time, one thread executes on the core. It's time slice, not my words, it's time slice. It's quantum of time. Its quantum is completed. That means if 5 microseconds was given to a thread, it will execute on the core. Its job is done. It will go back, and then it will take another thread to execute on the core. That's how it is. So the scheduling entity is a thread. If no threads are running, the program has got nothing to do and it will exit. Correct? That's how it is. So interesting stuff, friends. So now I will take you back to the point here, and then I will again take a pause, and if you have any questions, you can ask those questions. So please see this is the program that I have written. Simple, don't worry about what I have written and how it behaves. I grab some memory, 300 MB of memory I grab, and I put it into some data structure. I grab a memory and I put it into some data structure. I say system.out.println, and I put my program to sleep for a long period of time. Now I said I put my program, okay, not wrong, but essentially what I'm trying to say is that I put my thread to sleep. Which thread? The thread that is executing the main function. As I told you, you cannot imagine any program today without the thread. Even if it's not multi-threaded, so to say, even if it does not have hundreds of threads or 2, 3, 4 hundreds of threads, it will certainly have one thread at least. So in this program, I did not create any new thread. I did not create something new at all. I didn't write any code to create a new thread, and I did not put any code to execute in that thread. It's just simply public static void main. But if you are under the impression that this will run as a process when I start this program with Java, it's not. It's going to run as a thread only. Yes, process will get started, but within the process there will be a special thread automatically created. A special thread, once again, automatically created. One last time, your JVM will automatically create one thread to run this main function. And what will be the name of that thread? I repeat, what will be the name of that thread? What do you think? The main thread. I repeat, the main thread. And it is that main thread that I'm putting to sleep for long period of time. And since a thread is running, it's sleeping but it's still there in memory. It's sleeping but it's still there in memory. My program is also alive, it's running. It is nothing, it's doing nothing, it's dormant. My program is dormant. My thread is sleeping for a long period of time. It's dormant, but it's there in memory. Correct? You open MS Word. Okay, I don't do anything in draw.io. I'm not doing anything. Just not doing anything. I'm not even moving my mouse pointer. It's dormant, but it's there in memory till the time I do not explicitly close it or destroy it. So that's how it is. So my program, within my program, I've got the main function. Main function runs in its own thread. Correct? And if you want to know the name of the thread that it runs in, as I have already told you that the name of the thread is nothing but the main thread, and I don't have to spin that thread. It is automatically created by your JVM. I will now just show you system.out.println, and I'll say the thread name is, okay, I'll say thread dot current thread, whichever is the current thread. I repeat, whichever is the current thread. I don't care which thread, but I want to know which thread. So I'm saying thread dot current thread, whichever is the current thread in which this code is executing. I repeat, thread dot current thread will give you, when whichever thread this code is executing, get me the name of it. That's it. So thread dot current thread, this is a static function. This is the static method of this class. I have not created an object of thread. I just said thread dot current thread. This will automatically internally get me the thread in which this code is executing runtime, and it will get me the name of it. Let me now say Java C. Okay, I have compiled it successfully. Java. Now when I say demo, my dear friends, can you see this? What is the name of the thread? Come on. What is the name of the thread? The name of the thread is main thread. Super. The name of the thread is the main thread. Perfect. Did I create this thread? Yes or no? Did I explicitly create this thread? No. Who created this thread? One word answer. Who created this thread? Super. It is the JVM. You guys are brilliant. I'm enjoying. And I hope you all also are enjoying. You getting it right, friends? Right. Super. Brilliant. It's the JVM that is creating that main thread. Other than this thread, if at all I need to put some piece of code in its own execution context, not my words, if I want to put some piece of code that must execute in its own execution context, then I will have to explicitly create a thread of my own. I repeat once again, if at all I want some piece of code to execute in its own execution context, then yes, I will have to certainly create a thread explicitly, one of my own, and I will put that piece of code to execute in that thread. Pretty simple stuff. Got that, friends? Any questions, any doubts, absolutely feel free. However trivial, or you may think however wrong your question may be, there is nothing like bad question. There is nothing like trivial question. Please go ahead and ask your questions. I'm taking a pause. Okay, I will also put that this in front of you so that you can you can think of a question. Oh, okay. It will be too early to explain in the explain in detail about Java.NIO, but still I'll give you an overview here since you have asked for it. From 1.4 onwards, Java now, which is the current version of Java? Java 16, right? So until in Java 1.4 they introduced something called new IO. So Java.io is a package. Java.io is a package that is there since the inception of Java, since 1996. When did Java start? When did Java start? When was the first Java version released? Java 1.0 by Sun Microsystems. Yes, 1996, correct. It was 96 actually. All right. So, well, so maybe 1995, maybe, but as far as I remember and I know, it was 1996. Okay. So, Java.io. What is IO? Input and output. You will be able. So that's the package in which they provide components. They provide classes using which you will be able to read a file. You will be able to write to a file. You will be able to append it to a file. You will be able to search in a file. You will be able to read the file from the network, and you will be able to write to the socket. You will be able to open a network socket connection. You will be able to read over a socket connection. You will be able to write to a socket connection. Very rich library, Java.io. That was the package. Is rather now also you do have that package, and you do have loads of classes in that. But Java 1.4 onwards, they provide. Okay, JDK alpha and beta in 1995, JDK 1.9. Thank you so much, Bhartiya. Thank you. Great, thanks. That was good. Thank you, Bhartiya. I did not know about that alpha beta. Okay, so very nice. So Java 1.4 onwards, they introduced something called NIO, new IO, and they enriched. They further provided much richer, okay, library, and they provided features like reading the data into the buffer, and then manipulating the buffer, and then finding the data in the buffer, and then traversing through the buffer. That all that stuff was added in Java. And they introduced selectable channels. They provided multiplexing feature. So very advanced input and output related features were provided from Java 1.4 onwards, and all of those classes they provided in the library in the package called Java.NIO. Right? New IO. I hope that answers your question, Deepthi. Yes, good question, Anikenda. Right. So basis on many a times it so happens that you want to run a background task. You want to execute some task which will keep on polling for some data, maybe on some remote server. You want to maybe keep on polling for the new data that has come on a file, maybe after every 5 minutes or so. You want to keep on doing something in the background. Then in that case, you wouldn't want that thread to take up much of the computing resources, and you may make that thread as a low priority thread. In some cases, you are performing some kind of a sorting algorithm. You have written some algorithm which is very complex, some kind of sorting, or some shuffling, or maybe something else, some kind of a complex logic, and you want that particular piece of code, you want to put it into a thread, and that piece of code in the thread must execute super fast, and you want your operating system to give highest priority to that thread, because that is the main task that you are performing. You may want to increase the priority of that thread, right? So you may say this is a high priority thread. So in Java, the priority of the thread starts from 0 to 9 or 12, right? Okay, 12. From 1 to 12. 5 is the default. 5 is the default priority. So even if you do not set the priority, 5 will be the default. Any doubts, any questions? Very good questions. It will be 5. So if you do not declare the priority, by default it will be 5. 1 to 10. Yeah, okay, the priority is from 1 to 10, not 12. And you know what? We don't give priorities. In my applications, in our applications, we don't give priorities at all. Because, see, Java used to support something called green threads. Java used to support something called green threads until 1.2, Java 1.2. But from 1.3 onwards, it stopped supporting green threads. So you see this, if I say Java -green, it will tell me that green thread support not available. Can you see this? What do you mean by green threads? Green threads, when green threads, I mean, when this feature was available, that was the time when it was the job, the world was of uniprocessors. There were not multi-processor systems, multi-core systems were not there. 1.2, Java 1.2. I'm talking about 2002, 2001, 2002. And at that point of time, 2002 onwards. So at that point of time, there were very fewer machines that were multi-processor systems. So you had a choice of executing a program with hyphen green options. So what it used to do is that though you have 100 threads created in your Java, your operating system, and at the core level, at the kernel level, there was only one thread created, and all of those 100 threads were scheduled to execute in that one single thread, and the scheduling algorithm was with Java, not with the operating system. Operating system had its own scheduling thread, but Java used to not pass over the scheduling mechanism to the operating system. It used to, with hyphen green, it used to manage its own scheduling at Java level. When it used to manage, it used to consider the priority based on which it used to allocate the task or assign the task and give the task to be executed at the core. So those days are gone now. So what happens, even if I set the priority, it doesn't help me. Why? Because there is no guarantee. I cannot write now, note down this point, since we have picked up the point of priority. Note this down, it's 101%, that's how it is. That even if you give the priority, there is no guarantee that the operating system will respect that priority. It is still there, but I cannot write my algorithm which will be completely dependent on the priority. I can set the priority higher, assuming that the operating system will honor it and give better time slices and frequent time slices to my thread, assuming. But I cannot build some logic based on that assumption, right? So only if you are writing code which is very very you have got full control and you understand what you're writing, and if that you're keeping the priority high, you can very well do it, but do not implement any business logic. You cannot in fact implement any business logic that would help you to that would be dependent on the priority, saying that okay, if the priority is 9, then I do this, and if the priority is low, then no, you cannot do that. I said that is the reason we don't use priorities as such. Okay, good. Anything else, friends? Any doubts, any questions? Right? Good. Clear. Super. Okay, so now the rest of the things. Let's move on. Okay, so far so good. Now I'm going to go back to my JVM here. This is my JVM. Now I'm going to do what? I will increase the size of this box, right? And you know very well what we have talked about. So this is a processor. I'm going to bring this processor down out here. I've got my hard disk here. I'm going to bring this down here. Okay. And here you go. Perfect. Right. So this is the JVM that is running. Okay. So now this is getting more interesting. Now friends, you've got to pay very careful attention here, and this is going to be very, very interesting. So this is your JVM that is running. Now this JVM that we have, that is running here, it has got quite a few memory pools. It has got quite a few memory areas, and the memory management happens by your JVM. It's done by the JVM itself. The memory management is done by your JVM itself. JVM is very powerful. It does good amount of memory management. So when it interprets your code and compiles it into machine code and gets it executed, your code, when it starts getting executed, there are a lot of variables that you create, and there are a lot of data, rather I would say the data structure, and there is a lot of data that you need to store in some kind of variables. You need to store data during the execution of the program, correct? So how does it actually manage all of these things? So first of all, before I proceed further, very basic and the fundamental thing here. Of course, we are going to talk about this in more detail as we proceed further. But then understand there are two types of data. You can classify the data structures into two categories in Java. For that matter, all other programming languages as well, except for Scala and all, where everything is an object. But here you can categorize, into two. One is an object of some or the other class, and the other is the primitive data type. Please repeat this. You need to write this in the chat window. What did I say? There are two categories. One is what? One is what? Come on. One is the objects of a class. Yes, object of a class, and the other is primitive type. So you've got primitive and objects. Yes, primitive and objects. Objects are, so very simple English. Object is an object of a class. If there is a class, I can create an object of that class. Correct? Objects. Right? We are the objects of class human beings. This particular mobile is an object of class mobile phones. Right? This is an object of class, AirPods. This is an object of class mouse. So objects and classes. Class is a blueprint of how an object will look like and how will it behave. I repeat, a class is a blueprint of how the object will look like and how it will behave. What will an object look like and how it will behave? So if I have a class called human being, and there are properties of that class: age, height, color. So these are the properties. And then it has got behavior: walk, talk. These are the behavior. Some functionality written in walk, some functionality written in talk. So if you have an object of this class, I am an object of class human being, I will certainly have age, height and color. The value would be, whatever the values are. And how will I walk? Exactly based on the functionality that is written in walk function. How will I talk? Exactly based on the functionality that is written in the talk function. So the object will behave based on the functions that are declared in the class, and the object will look like, how will it look like, based on the properties defined in the class. So the objects are always the objects of some of the other class. This is one point. And the second is primitive types. Primitive types are not objects. They are kind of quite native to the operating system. But in Java takes care of that nativity as well, because even if you create a primitive data type in Java on a Linux operating system, the max value of it, the min and the max value of it will be as same as you deploy the same application on Mac or Windows. The min and the max value will still remain the same. But it's primitive. They are not objects. They are not objects. So how does it differ? So I'll come to this in more detail as we proceed further, objects and primitives. But then you need some memory space in order to store these objects and primitive types. Yes or no? You definitely need some space in memory. So this is your JVM. This is your program that is running. What it does is that it sets aside a memory space called Java heap. I repeat, it sets aside a memory space called Java heap. Very simple stuff. Heap, if you go into if you go to the market these days, you will get heap of mangoes. You will have heap of apples. If you go to the fruit market, heap of something. Java heap. What does this mean? The objects in Java will be stored here in this memory space. As simple as this, right? Java heap. Java heap. So this is where the objects will be stored in Java heap. This is exactly where the objects, this memory area, the objects will be stored. So when I create an object of class string, that object will be stored here. If I create an object of class say integer, it will be stored here. If I create an object of class customer, that customer object will be stored here. If I create an object of class product will be stored here. If I create an object of class purchase order, that purchase order object will be stored here. If I create an object of class rectangle, the object of that class will be stored here. So the objects are stored here. This is the space. Java heap is the space where the objects are stored. Right? This is Java heap. Now, where are threads? In the JVM, where are threads? One is the fact that the thread is executed here on the core, correct? But then when you create threads in Java, and when the threads are internal threads of Java, where are those threads? That each and every thread is represented by a thread object. So the thread object, since it is an object, it is still here, but don't worry about the thread object so much. But then the execution of that thread happens in a data structure called stack. I repeat, the execution happens in the data structure called stack. So you remember when we wrote our program, there was something called main. There was something called main function. You remember the main function? So that main function will execute in a thread. Please recollect, what is the name of that thread, friends? Tell me. What is the name of the thread in which that main function executes? Tell me. Correct. Superb. Superb. Very nice. Very nice. Brilliant. Very good. So it is the main thread. It is the main thread, right, in which the main function gets executed. And then while that thread is running, do you think the other thread, if at all I create another thread, do you think that thread will stop the execution of main? No, it will not block. Rather, stop is not the right term. It will not block the execution. Main will keep running. While main is running, another thread, maybe T1, I call it T1, that thread is running. And maybe while T1 is running, I have for some reason to execute another execution, some piece of code in another thread. So maybe T2 is executing. While T2 is executing, I may have T3 also executing. All of these are what kind of data structures? They are stack objects. I repeat, these are stack objects. And I'm sure in your computer programming courses, or in your college, you might have come across data structures which are of type LIFO, last in, first out. If you are standing in the queue for your, maybe you want to take a bus from one place to the other, and if you are standing in the queue, you are in FIFO mode. The first person who comes will be the first person to get into the bus. First in will be the first out. But if you are putting cookies in the jar, the last cookie that you put will be the first one to come out. That is stack. So one is the queue of the bus queue, the first in, first out. But in case of a stack data structure, it's like a cookie jar, So last in will be the first one to come out. So you see this, main is the function that you have written that executes in the main thread. I repeat, it executes in the main thread. I repeat once again, it executes in the main thread. And while the thread is executing, there are other threads also that will keep executing in parallel. But from the main thread, don't you think it is quite possible from the main function that is executing in the main thread? Note my words. Don't you think that the main function that is executing in the main thread, you may end up executing other functions? Subsequently, other functions, function from a function, main calls some function makes a call to yet another function, that function makes a call to yet another function, and so on. Don't you think it is quite possible that you keep on executing those functions? So where do you think those functions will be pushed? This is a stack in the same main thread. And as those functions gets completed, they will be popped out, and then the last function that remains is the main function, that also gets popped out, and main thread is completed. It is eligible for garbage collection. Don't worry about garbage collection, we will talk about that later if time permits. That's how it is. Now it's high time, in order to start writing code with with speed. I will now not use my the editor, VI editor. I will get started with my IDE. I don't want you all to write code along with me. I don't in fact want you all to write the code that I'm writing. This is something very interesting and important that you must understand theoretically how it really works. Okay, so I will create a new project. Don't worry, I will explain to you and how to create a project. I will handhold you when I want you to do it on your machine. As of now, just see, I am creating a new project. Okay. Okay. So now A new project is created. We are using IntelliJ. I expect you all also to use IntelliJ during this training program, but even Eclipse or NetBeans or any other IDE is also good enough, but nothing like IntelliJ in this world, you know. Okay, so I have got my, don't worry about this entire structure of this project. Don't worry about that. It's a plain simple Java project, and always, whenever you create classes, you better create a package, and I'll say com.pwc.training and I'll say Java. So it's a Java training, and within that I create a class and I give the name of the class as demo. Okay, and within the demo class I have my main function, same stuff, but I'm writing it in the project in some different folder. The project is created and I have an IDE to work on my project. So you see this, I have created a main function. Now don't you think it is quite possible that I have another function here called public void f1, and you see f1, and I will make this also static for a reason, otherwise I will have to create an object and stuff, which I don't want to get into. So this is my f1 function. Similarly, suppose I have a function called f2, and then similarly I've got another function called f3, suppose. Okay, f2, and then I have yet another function here. Okay, and then I have yet another function, and I will call this function as f3. So please see what I'm doing. From the main function I'm making a call to a function called f1. From f1 function I'm making a call to f2, and from f2 I'm making a function call, I'm calling a function called f3. So I've got a main function. From main function I'm making a call to f1, f1 makes a call to f2, f2 makes a call to f3. You see this, and then that's it. I mean, of course it can go on and on and on. So how do you think the things will happen? First of all, once again, I want to see the answers in the chat window. In which particular thread do you think this main function will be executed? Tell me, in which thread will it execute? Tell me, in which thread? In the main thread. Exactly, super. So it is the main thread in which the main function will be pushed into the stack. Note my words, this is the name of the thread. This is the name of the thread, but the name of the function is what? Which function gets executed? Main function gets executed. That function gets executed, that is pushed into the stack. I repeat, it is pushed into the stack. It starts executing. It starts executing. Correct? And then you have, the main function in turn makes a call to which function? Main function makes a call to which? This is irritating, so it keeps on notifying. Okay, so you see this here, I'm back again here to my IntelliJ IDE, but then I'll go back to my draw.io as well, right? So you see, from main I'm making a call to f1. So tell me which function will be pushed into the stack. Tell me what will start what will execute now. It will put f1 into the stack, and f1 will start executing. F1 starts executing, but it sees that from f1 you're making a call to f2. Now f2 will be pushed into the stack. F2 will start executing. From F2 you're making a call to F3. F3 will be pushed into the stack, and F3 will start executing. F3 will start executing. You can see this? F3 will start executing. So F1 from F1, F2 is executed. So F2 is pushed into the stack. From F2 you make a call to F3. F3 is pushed into the stack. In real life there will be hundreds of such functions that will be put into the stack, and they are executing. Now F3, for example, completes. It completes. F3 completes. You see this? F3 is executed. F3 completes. Suppose F3 will be popped out. What will resume? Come on, what will resume? When F2 is, yes, exactly. F2 will resume. F2 is popped out. What will resume? F1. F1 is popped out. What will resume? Main. Main is completed. Main is popped out. That thread is done. The thread has now terminated. The thread has now terminated. Once again, I will repeat, the thread is now terminated. The thread goes through different stages. It is in the start state, then runnable state. It may be in the block state. It may be in the timed waiting state. Again, I repeat, it may be in the waiting state, and definitely towards the end of it, it will be in the terminated state. These are the 6 different states. Don't worry, we will discuss about the states later, but then otherwise that's how it is. But even if the main is completed, note my words, liklo. Out of 100 programmers, Java programmers, when I ask them, they are unable to answer this question. They think that the main thread is always running and keeps running. No. If the main thread has completed, it is completed. It's gone out. It's lost. It's gone. Your JVM may still keep running, because if there is any single other thread, even if there is a single thread running, which is a non-daemon thread, we will talk about daemon, non-daemon later, but even if there is a single thread running in your JVM will keep running. Even if there is a single thread running in your JVM will keep running, though the main might have completed. But if there are no threads running, neither a main nor anything else, if there are no threads running in your application, then in that case your JVM will exit. I repeat, your JVM will exit. Any doubts, any questions on this? You got that? No, perhaps what you're trying to say is Stack Overflow. See, when do you think Stack Overflow happens? When do you think Stack Overflow will happen? When you have, see this, suppose from F3, I make a call to F3 again. Okay, from F3, I make a call to F3 again. What will happen? What will happen? Tell me. Tell me what will happen. If from F3, I make a call to F3. And I keep doing that. I mean, that's how. I'm just doing this. What will happen? F3 will be pushed into the stack. Again, F3 executes. F3, you're making a call to F3. Again, F3 is pushed into the stack. F3 is pushed into the stack, and you will have all F3s, and the function, it never ends. And there is a limit to the amount of there is a limit to the size of this stack data structure. This is a data structure. This is a memory space. This is memory space. There is some specific size to it. So the moment it reaches that size, your Java, because now there is no more space to push other functions here, it will result into Stack Overflow error, and that is an error. So you see this Stack Overflow. You can see this here. This is an error, not an exception. So throwable is on the right, is right on the top, and then you've got error and exception, and from exception. So we will come to that later when we talk about exception handling in Java. But then otherwise, it will result into fatal error, that is Stack Overflow. Right? So that's how it is. Okay. Right. So this is how it is. So far, so good. So you have multiple threads, running. Now I would like to show you how, how on earth I create a new thread. Now it's pretty simple stuff. You see. If you ask people out there, all with me, friends, come on, all with me. All are there? I'm sorry, I will keep on asking this. Because in a classroom-based training program, I'm seeing people right there in front of me, but here when I don't see people, I need to make sure. Very good. So you see, if you ask people out there, multi-threading in Java, they say, oh, it's an advanced topic. But I call it fundamental in the basic topic, and it's the most fundamental thing. If you don't understand this, you will not be able to write effective code in Java. So now I have another question, a bit of a tangent here. Another question, not related to Java. How do you classify things between basic and advanced? Take your time to answer, but do answer in the chat window. I would expect at least 2-3 answers, at least, if not all 25 of you. How do you classify things between basic and advanced? What is basic? What is advanced? Okay. Yes. Anindya. Very nice, Anindya. Very good. So see, I have my own way of classifying things. Basic is what we need to comprehensive understanding. Okay. Okay, not bad. I have my own way of classifying things between basic and advanced. Something that I understand today is basic, and something that I don't understand today is advanced. Right? That's how it is. For Albert Einstein, E is equal to mc square was basic, isn't it? But for some of us, it's Greek and Latin, perhaps. No, not so much, but we understand. But then that's how it is. So it's just a matter of knowing things and not knowing things. Yeah, okay, not wrong, Devdeep. You're right. You're right. Okay, but then level of working with, yeah, Chandana. Okay, not wrong, not wrong, Chandana. You are also right. But this is how I have explained to myself what is basic. So this is something that appears to be advanced to me today. It's just because I am unable to run my head around it. I am unable to get my head around it. Today it's advanced, but the moment I start digging into it, the moment I start working on it, I realize within a day or two I keep on 8 hours, 10 hours, 2 days, 3 days, and I realize, oh my god, this is like this is pretty simple. So that's how it is. So please don't think thread or multi-threading is an advanced topic that we have started with, so to say. Fundamental, it's basic, and if you have conquered this, you're done. Right? Everything else is just the matter of putting in time to see, okay, this is what it does, this class does this class does this library does this, that library does this. You will be in pretty comfortable situation. So let's move ahead. So what I'm going to do now is I will just simply do away with this kind of code, okay, and I don't say F1 and stuff and all. Instead, what I'm going to do is that I'm going to write a thread of my own. So I can create a class here, and this class is like, for example, I say vacation thread, something like that, right? And I'll extend this from a class called thread. There is actually a class called thread in Java. I'm creating a simple class. Extending that class means inheriting that class from thread class. What is inheritance? Pretty simple stuff. Come on, you all are all expert guys, you all are all intelligent people. It shouldn't take more than a few minutes for you to understand what is extension and what is inheritance. Very simple. I have inherited the features of my father. My father has some features. I am the son of my father. I am going to 101% inherit all his features. Yes, I do have rights to override it. Yes, inheritance. Yes, exactly. Yes, perfect. So when I inherit the features of my father, I have the choice of overriding it. But I also can have my own specific features. But one thing is for sure, my father's features will be inherited in me. Correct? So for example, my father has got a feature called saving. He saves money. I will certainly have the habit of saving money, at least as per Java programming. So I save. Now I can override. Perhaps he has got the habit of saving. His functionality of saving is, out of a rupee that he earns, he saves 25 paise. And perhaps I override it. Out of 100, out of a rupee that I earn, I save just 10 paisas. So that's, but I am saving for sure. I do have saving functionality. But I am overriding the behavior. I am overriding the functionality. That is possible. But features would be certainly there, right? Inheriting the features of the superclass. So you see this. We have here vacation thread extends from thread, and here I will just simply override, because thread is the class. Never ever shy away from getting into the source code of Java classes. See, this thread is the class that I have not written. When I move my mouse pointer here, you see it very clearly tells me java.lang. That public class thread, it is, where is it? It is java.lang. It is in the package called java.lang. Okay, so your thread is the class. I can always control click on it and I can get into the source code. This source code is not written by me, it is written by the implementers of Java. Cool. And then here when I say command O, here on your machines it will be control O, you will find that there is a method called run. Can you see this? There is a method called run. It is this run method that gets executed when you start a thread, not my words. You never run the thread. You never ever will run a thread. You will never ever run a thread. You will start a thread and the run function will be executed by your JVM. Interesting stuff. I'm repeating once again. You never run a thread, you start a thread, and when you start a thread, it automatically ends up executing whatever you have written in the run method. So this is the run method, which is the default implementation. I will call it, because I did mention that I am very particular about making statements. Each and every term that I use, or when I'm making a statement is extremely important. You must catch. Okay, so this is the default behavior. I want to override this behavior, so I will say run method here in my, you remember I did said, let's say if my father has got the feature of saving, I will also have the feature of saving, but I can override it. I am overriding this automatically. When I'm using the hotkeys of this IDE, it automatically does that after it override and stuff. Okay, and you see there is an arrow here. This IDE is very smart, very beautiful, very elegant, state of the art, right? You have community edition as well as the ultimate edition. You all have community edition. You may not have all the features, but then yes, almost all the features that you need for Java programming. For other frameworks, for other programming, yes, you need an ultimate edition, especially for front-end programming, but we are not learning and we are not going that way at all. So it's Java. You will find all of these features almost there in your community edition as well. And you see this public void run, so it's making a call to the superclass. I don't want that. As I said, I want to override it. And as of now, I'm writing just one thing. I'll write while true, and I will write here system.out.println. Okay, I'm writing system.out.println. I've used the hotkey SOUT. I will type and use tab. It will automatically put system.out.println. Correct. All right, friends. Okay, so system.out.println, and then here I am saying this code is, or I would rather write this line is executed. I want to write in which thread. How do I get the name of the current thread? Tell me. How do I get to know that this piece of code is running in which thread? Tell me, what is it that I'm supposed to write? I'm taking a look at the chart here. What do you think? Tuta puta bhi chalega. Yes, and he can do yes. Very good. Yes, Anand. Yes, Abhijit. You're close, Abhijit. Very good. Yes. Very good, Rakesh. You are the closest. So you see this, I'll say thread dot current thread dot get name. Now since I'm using the IDE, so it's it's very elegant, and it gives me the drop down and stuff and all. So you see this will give me the name of the thread. Now how do I start this thread? I will write something like this. I will say vacation thread t1 is equal to new vacation thread. That's how. And I did mention, if I want to execute this thread, if I want to start this thread, will I say dot start or will I say dot run? Tell me. I did mention this 2-3 times. If I want to start a thread, I will say dot start or I will say dot run. Super. Correct. I will say dot start, and it will automatically end up executing which function in the thread? Which function will it actually execute when I say dot start? Yes. No, not the main, Anand, not the main. When I start my program, it will run the main function, but then from the main function, what am I doing? I'm creating a new object of vacation thread, which happens to be a thread, and then here I say t1 dot start. You can see this. The moment I say t1 dot start, this will execute in its own thread. This piece of code will run in its own thread, and I will get to know in which thread it is executing. But you know what? This will be super fast. This will just, while true, is this loop going to break or it is going to keep on executing? What do you think? It will be an infinite loop, yes or no? Yes, Rakesh. This will be an infinite loop. There is no way to break out. So what I'm going to do here is that I will just simply, I'll say thread dot sleep, not to break the loop. I will still keep it as an infinite loop, but I'll say thread dot sleep. Which thread will sleep for 1 second? Which thread do you think will sleep for 1 second? I will have to surround this in a try catch block like this. Tell me which thread will sleep for 1 second? The thread in which the code is getting executed. Whichever is the thread in which this code is executing, and that happens to be a separate thread as compared to the main thread. Main thread is the thread in which the code will execute. All of this code will execute in the main thread. But the moment I start a thread, the run method of that thread will execute in a different thread altogether. I will get to see the name of the thread, and it will also keep on printing, system.out.println, whatever is the name of the thread, it will keep on printing. It will just move on and on and on. And then you see this, let me execute this and you will get a better view. See, I'm executing my main, and you see this, it starts my application. Okay, you see this, the line is executed, you see, in thread 0. So where is this piece of code getting executed? In which thread? Is it in the main thread or it is in thread 0? Come on, tell me. It is executing in which thread? Thread 0, exactly. Who created the thread? Was it implicitly created or I explicitly created the thread? What do you think? Yes, I explicitly, yes, we created the thread here. We created the thread and we started the thread, and it implicitly named that thread as thread 0. It implicitly named that thread as thread 0. Fine, it's okay, no problem. That's fine. Okay, and I can terminate that from here. Absolutely, I have terminated. I'm clearing it off, so I have stopped my program. So now in this case, my dear friends, thread the vacation thread the T1. If I go back here, this is that thread T1. Now from this T1 thread, suppose my question to you is this: I am executing system.out.println, I am executing thread.sleep. Suppose from here also I do execute something like this, I'll say F1, and then I execute, I execute F1, and then I execute from F1, I execute F2, and then from F2 I execute F3 and stuff and all. So if suppose I do that, where do you think, in which thread do you think? I'll repeat my question. If I start executing the functions from here onwards, from here, in the same thread, I execute the functions. So those functions which are in this thread will be pushed into which one of the two threads, main or T1? When I call the functions from T1, needless to say, it will start pushing the functions in T1 thread, na? Isn't it? From T1, it will start in T1 thread, it will start pushing the functions, and when everything is completed, the entire flow is completed, then after that the thread has got nothing to do. It will come out and it will be eligible for garbage collection, and the state of the thread will be terminated. As in this case, you see, I will do what, I will put here new date. Each time new date is encountered, it will create, or else, okay, yeah, that's okay. So the moment it encounters, each time it executes new date, it will give me a new timestamp. So please see this. So I will keep on getting new timestamps here every second, and it will, you see, second by second. Can you see this? 28, 29, 30, 31. Can you see this? 32. You can see this? It goes on and on and on. 35, never ending. But now what I'm going to do here is that, I'll declare a counter here. Okay, let me stop this. I will declare a counter here. There are various ways in which you can do this. I'll say int count is equal to 0, or let me make it 5. And then I will say each time it goes into the while loop, I'll say count minus minus, which is as good as writing count is equal to count minus 1. Okay, it is as good as writing that. And then I'll say if, I'll say count, okay, is less than equal to 0, or I can just simply say equal to 0. Eventually, after saying minus minus, it will reach to 0, and then I say break. What will this do? Okay, of course there are better ways of writing while loops stuff and all. There was no need to do the circus of first defining the variable stuff and all, and then minus minus out here. I could have used a for loop also. That's fine. That's besides the point, and that's not what we are discussing. So the main focus here is that it will execute just simply 5 times out here. So I click on this now in order to run this, and you can see my thread will be terminated after based on the logic that I've written. So you see 1, 2, 51, 52, 53, 54, 55, done. It's out. It's out. I'm out. My program is terminated. Can you see my program is terminated? I'm running once again. You see my program is running. You see red button here, it's running. Okay, after that it's done. It's out. Why? Because now there are no threads. There are no threads. So the main was running fine, but main got completed immediately. Now you see this, what I'm going to do. I'll add s out and I'll say main is completing, is about to exit. So this thread will exit. This thread will exit, but still my JVM is running. Why? Can you answer? Can I get some 2-3 people answering this question? My question is, my JVM will still keep running, though it will encounter the statement. See for yourself. See for yourself. It has encountered the statement main is out, about to exit. Main is gone. It's gone. Uska job khatam ho gaya. But still my program is running. Why? Can you put that? You are seeing that right here in front of you. But can you put that in your own words? I will appreciate if at least 2-3 of you all give me a very good answer out here. No, not because of thread sleep. Good try. Yeah, but because of the thread, you are very close, Chandana. No, main doesn't need to run throughout. T1 is still running. Yes, T1 is still running. That's the point. Yes, Rakesh, thread 0 is still running. That's the point. Thread is there, so JVM is running. Yes, Bhartiya, you're right. Because this thread 0 is still running. Thread 0 is still running. Yes. And the moment thread 0 also completed, main anyway is completed. Thread 0 is completed. Am I right? Thread 0 is also completed. Okay, the JVM is out. So now you tell me, look at this code and tell me for how many minutes do you think, for how many seconds do you think your Java, this particular Java program is going to run? Take a look at this code and tell me for how many seconds do you think this Java program is going to run? For how many seconds do you think this Java program is going to run? Very good, 5 seconds. Okay, why 6? Rakesh, extra 6 seconds. Extra 1 second forward. 5, right? I think 5. 55? No, you're trying to say 5, it seems. Yes. Yeah, correct. 5. Yeah, so 5 seconds, approximately 5 se thoda upar, theek hai, but then otherwise 5 seconds is what is going to execute. Now see what I'm doing. If I write, and you have seen thread.sleep over here. So which thread is going to sleep here? Thread T1, the one that is in which I've written this code. I'm now saying here thread.sleep. I'm saying 7. I'm saying 7. 7,000 milliseconds is 7. Now you tell me main thread will execute all of this code. It will start a new thread. That thread will run for 5 seconds, but this main thread will get stuck over here. It will go to sleep for 7 seconds. Now tell me all in all, for how much time will this Java program execute? I will be the happiest person on earth if I get at least 50% right answer. Achhe se dekho, don't haste. And please recollect all that we have discussed. 2 threads run in parallel. One doesn't block the other. Tell me for how much time, all in all, approximately, for how much time do you think this Java program will run? Brilliant. It's worth spending time and effort while training people like you all. Super. Brilliant. Exactly. So this is going to take 7 seconds. All in all, this is going to take 7 seconds, right? So this is on. Okay, so see, 14, 15, 16, 17, 18, but still my JVM is on after 2 seconds. Now it's off. You notice that, right? After 18 also, so you see it starts now 26, 27, 28, 29, 30, and then 2 more seconds, right? Because that thread is in parallel, it is running. So it's like, this thread is taking 7 seconds, right? But one doesn't block the other, right? I'm so very happy no one told me 12. Really, you made my day, my dear friends. I'm not exaggerating. Really, you made my day. No one said 12. Why? Because otherwise, if you say 12, then I mean, all the discussion that we have done, goes down the drain because it doesn't make sense, right? Because that's what thread is all about. On one core, one thread will be executing on the other thread, on the other core, the other thread will be in parallel executing. Correct? So I have my main, and then this is my T1 thread. That kind of logic that I have written. See, it's not that you will always be able to predict, my dear friends. Here we are predicting because we have hard coded everything. We have just hard coded thread.sleep 5 and thread.sleep, 1 second, and then the loop goes on. And then, we have hard coded thread.sleep in the main function as 7. So we can predict well, not that in every multi-threaded program you will be able to predict how much time will it take. But then this is a runtime, it may change, the parameters, so this is how it is. It takes 5 seconds, but both are. So all in all, the entire job is completed in all in all, if you say 7 seconds, the program gets completed. That's how it is, my dear friends. That's how it is. Okay. Now, the next thing that we are supposed to discuss is creating of objects. So when we start creating objects, those objects are they get created here in the heap area. Now, this is again extremely important as talking about threads. So we are not discussing, I did not discuss with you all how to write a multi-threaded application. So say some, complex applications, but the very fundamental thing, how your Java program runs, that's extremely important for you to understand. And that's how we started with this. Now we are supposed to talk about objects. We are supposed to talk about objects, how objects really work, how the objects are created, how the objects are referenced, how are they different from primitive types, how in memory actually it looks like, and quite a few other things with respect to objects. And I talked about the threads. So like, for example, this is also a thread, and maybe this is also a thread, just in order to make it look good. So it's just, this is just for representational purpose. But then otherwise, you also have another memory pool here, which is the non-heap area, which is also known as, from 1.8 onwards, it's known as metaspace. And then it was known as permanent generation in earlier versions prior to Java 1.8. Okay, that's how it is. This is another memory pool. We will talk about this memory pool later. This is also extremely important for you to understand, so that today the stage is set. I mean, from after today's training is done, my dear friends, it's like you have dissected Java. Everything else will become cakewalk, right? Everything else will become cakewalk for you. Okay, that's nice, that's good. So मुझे भूख लगी है, and I'm sure even y'all would want to take a lunch break. So I suggest we take a lunch break here. We will take 1 hour of lunch break. It's 1:20 and we will be back at 2:20.